Okay, hey guys. This is going to be two videos that I'm going to make for you. I got an email where a student was asking me to look at questions 6 and 7 on the worksheet. So I thought I would try to do most of question 6 and one of the situations listed in question 7. Now, question 7 I'll talk about in the next video, so right now I'm just going to stick to question 6, where, let's take a look at it. It says, you are jumping out of the shower and walk up to the mirror, which is now fogged over, so you can't see your face because the mirror is all foggy from all the hot water in the room. And so you're going to wipe away water to get a view of your face. So the question is, like, how much height in comparison to your own face would you need to wipe away so that you can see a full view of your face in the mirror? So I gave you 4 possibilities: 1/4, same height, half of the height, or is it always different? Does it depend upon your distance from the mirror? So let's take a look at that. Now, what do I always think you should do in these situations? Well, if you paid attention to me at all, you know that what I will always want you to do is draw a picture. So let's take a look at that. First, what I do know is that I will have a mirror. I'm going to have a mirror, let's say, right here. And just to make sure we know what side we're dealing with, this is the back of the mirror here. Let's just draw that right away. And I am standing in front of the mirror, and most importantly, what I'm talking about here is that I am looking at my face in the mirror. So let's see, I'm just going to draw myself a face. Looks pretty good. Pretty good. There's my face. And importantly is that I'm looking at the mirror through my eyes. I'll give myself a there. Very nice. Now at the same time, I know that there will be image of the mirror. Now, since I'm saying that this is a plane mirror, we can assume that it's a plane mirror, not a curved mirror or anything like that. That means that the image will be just as far away on the inside as it is on the outside. So whatever, let's see. Now, I got to make sure I do this right. So let's see here. I need to test it out. So let me just draw something else here. I'm going to draw a line, a straight line from my nose to the mirror. And I'll move that stick over to this side because I know that to do this right, I would have to make sure that my nose is also right there. Okay, so that's pretty good. That's pretty good. So let's just get rid of that now. So let's think about this. So we're assuming right now that the mirror here is all fogged up. It's all covered in water. So I'm just saying, how much of the mirror, how much of the surface of the mirror do I need to be clear? Do I need it to be in order to see my face? So the best thing to do is to consider how I'm looking at it. Okay, well, if I'm seeing this image, that means really, if I had to think about it, I'm looking at my whole head. That means I'm looking from the top of my head to the bottom of my head. So if I was going to do that, I should draw, let me see, from my eyes, because I'm looking with my eyes. So we'll just say right here, here's my eye. I am looking from the top of my head, let's see, from there, to the bottom of my head. So that's sort of the angle, the full angle of my view of and this is the same height as my head. So, and I know that the image already, this distance from here to here is the same as my distance from my real head, top of my head to my chin. So the question is okay, let's see that now for instance. I'm looking at what is the distance from here to here. I know that is the height of my head. Now, what I want to know is what's going on here. I'm just going to get another color here. I'll just go with blue. Is that at the same time, I'm also want to know how much of the mirror, so in other words, how much of this do I have to clear away? So what's interesting is that when you think about it, I have actually similar triangles. That's what I'm dealing with. So I've got a blue triangle. There's that triangle. And then I've got a red triangle. I've got these two triangles to deal with. And the question is, can I figure out the difference between the two, I guess, sides here? Is this thing related to this side in any kind of way? So let's just think about that for a moment. See if we can't think of a few ways of looking at this. Let's see now. What are some things that I know? I'll just put this all in yellow here. Well, I know that this is the here for the red one. I'll just move these apart a little bit here. Move this one over here. Okay, good. I know that this guy is the height of my head, and I know this. So this is the height of the head. We'll call this height 1. I know this is the height. I got clear away on the mirror. I'll call that height 2. Now, these are similar triangles, which means I also know that this angle, angle 1, is equal to this angle. In fact, all the angles are equal. I could say that this one's equal to this one, and this one is equal to this one. Now, what else do I know? Well, I also know that if I looked at the height of this triangle, at least from here to, let's say, this base, this would be a distance x. And that's the distance from my eye all the way over to the line over here. Now, what would be the distance for this one, for the height of this guy? Now, this is kind of interesting. So this one's x. Now, if you think about it, the mirror, which is only as far as this triangle goes, the mirror is actually half of that distance, because I have to double the distance, which means this is actually equal to 1/2 x. Now, wait a minute. Maybe this can help me out quite a bit, because if I think about that, that means I actually have parts of triangles, really, that I can look at. I could say, well, wait a minute. That means this angle, let's call it, I don't know, theta 3, is equal to this angle. We'll call it theta 3 as well. Now let's just draw this here. Let's just clear everything away and think about that for a moment. What are we saying here? I'm saying I've got one triangle that has, it's a 90-degree triangle and has a distance x. And then I have another one that has the exact same angles. It's a 90-degree angle, and this one is going to be 1/2 x. So the question is, this one is h1, this one's h2, and what is the relationship between these two? I don't know. But maybe there's something I can do to solve this problem. Now, if you think about this, I'm pretty sure that what's coming to your mind is that, well, wait a minute, if I know this angle, I know this angle, let's just call these, I'll call this theta 1, and this one's theta 1. I can actually do a little bit of trigonometry. So let's just take the first triangle. I could say that, let me see, this is opposite over adjacent. Wait a minute, okay, so I could say that tan of theta 1 is equal to x over h1, h1. And then with this triangle, tan of the same angle, I shouldn't call that 2, it's theta 1. Tan of the same angle is equal to 1/2 x over h2. Okay, so wait a minute. Let's look at that then. Let's bring all those down. So in other words, let's just do a little substitution. I am saying that x over h1. And remember, h1 is the h1 is equal to the height of my head, height of head, whatever it might turn out to be. And that is equal to x. Now the half, I can bring the 2 down, so that's actually more, I'm actually just simply saying this. And h2 is the height on mirror. x and x, that's gone. So that means h2, the height on the mirror, would be equal, if you look at that, I can bring that one up. I can bring this guy up. These guys can cancel. And I'm left with is the height of my head divided by 2. That's all it is. And notice I didn't seem to care about what distance I'm from. So this must be workable for any situation I got. So in other words, if I got this happening, I should be able to see, can I? Let's just see. So if I'm looking here, and then I'm looking here like that at my head, if I look at these two, and it looks about right. The distance for the blue is about exactly half that of the red. So everything I said before with this, oh, that's a bit of a mess. But really, what was I coming to terms with there was that H2, in other words, this little guy, is equal to H1 divided by 2. So that gives me my answer. That's how I solved the problem. So I should take that away there so you can see it a little better. So that's how you solve it. And in fact, most of these problems, what I highly recommend you do every single time is that you draw the picture. Draw the picture and look at where all the light is going. Picture either the light coming from the object to the eye or leaving the eye, just like the Greeks used to do, with it bursting from the eye to the object. And then say, okay, well, if it's hitting a mirror, does it reflect? Or if it hits some water, does it refract? You have all the rules already on all these different things. So question 6 and 7 shouldn't be too hard for you to do, but you have to think about all the things you know that light does when it hits another medium or when it hits a mirror or when it hits a curved mirror. So that's what you have to think about. Now you have all this information you've learned about lenses, mirrors, refraction, and reflection. You have to use them to answer these questions. So I'm going to answer one of the questions on question 7, not all of them, just one of them. And I think that will at least get you started on how to solve those problems. So I'm going to look at them in the next video. So I'll talk to you then.